Suppose we got a particle and the particle is moving along the circular path. By using vector differentiation, we can find out the velocity of the particle as well as the acceleration of the particle. Suppose O is the center and P is the position of the particle. Let us call the coordinates of the point P as a x comma y. Let us talk about two dimension. Join the point O and P. Let us call the vector OP, that is denoted by vector R. So position vector of point P, position vector of point P can be written as vector OP, that is equals to vector R. Vector R can be written as x into I cap plus y into j cap. Let us say this is the x-axis and this is the y-axis, and angle made by the position vector with respect to x-axis equals to theta. Let us draw this projection on x-axis and call it this distance as a x on x-axis and vertical distance be the y. Now the magnitude of vector R equals to R, because if you want to find out the components of vector, x component and y component, then you require the magnitude. You cannot consider the vector quantity. Therefore here I have magnitude of vector R equals to R. Now from the figure, sin theta, what is the sin theta? Sin theta nothing but opposite side upon hypotenuse. Therefore y equals to R sin theta. Keep it as it is. I will use in the next step. Similarly, cos theta equals to x upon R implies x equals to R cos theta. Keep it as it is. We will be using in the next step. We have vector R equals to x into I cap plus y into j cap. Therefore, vector R, what is the x value? X is nothing but R cos theta. So vector R equal to R cos theta into I cap plus y. What is the y? Y R sin theta. R sin theta into j cap. So we got expression for position vector of point P, that is vector R equals to R cos theta into I cap plus R sin theta j cap. Now, as the particle is moving along the circular path, the direction of linear velocity changes from here. The body moving along the circular path, the direction of linear velocity is changing. As the position of particle is changing, the direction of linear velocity changing. We have the vector R equals to R cos theta I plus R sin theta j. And we want to find out expression for vector V. That is the expression for linear velocity in terms of vector. So vector R equals to R cos theta I cap plus R sin theta j cap. Differentiating both sides with respect to t. So we have the dr by dt equals to differentiation of R cos theta I cap plus R sin theta j cap with respect to t. Here derivative of R is a constant, so keep as it is. Derivative of cos theta is minus sin theta, and theta is a function of time. So more the time, more the theta cover. Therefore, theta is a function of time. Theta depends upon time. Therefore, we need to do the derivative of theta even. So derivative of theta is nothing but d theta by dt. I cap will remain as it is. And again, R as it is. Derivative of sin theta is cos theta, and derivative of theta is d theta by dt, and j cap will remain the same. This can be written as minus R sin theta d theta by dt I cap plus r cos theta d theta by dt j cap. This is equals to dr by dt. Now d theta by dt nothing but rate of change of angular displacement is nothing but omega, and dr by dt nothing but rate of change of displacement, that nothing but vector v. Therefore vector v equals to minus r sin theta. In place of d theta by dt, write down omega I cap plus r cos theta omega j cap. Taking omega common, I cap r cos theta j cap, and omega is written outside the bracket. This is required expression for linear velocity. Required expression for linear velocity of particle performing circular motion. Now we will find out expression for acceleration of the particle. Acceleration of the particle is nothing but derivative of v with respect to t. So differentiating both sides with respect to t. So dv by dt equals to derivative, r will remain the same, derivative of sin theta is cos theta, and derivative of theta is d theta by dt I cap plus r as it is, derivative of cos theta is minus sin theta, again derivative of theta is d theta by dt j cap multiplied by omega. Again here is the d theta by dt, here also d theta by dt, d theta by dt can be replaced by omega. D theta by dt equals to omega, that is the angular velocity. Therefore dv by dt equals to minus r cos theta omega multiplied by I cap plus minus r sin theta omega multiplied by j cap, and outside the omega is already present. Now dv by dt nothing but acceleration. So vector A equals to, and here is a minus can be taken common, and omega as well as can be taken common. So we have r cos theta I cap plus r sin theta j cap, and one omega already present there. We again taken the omega common. So we have vector A minus here r cos theta I cap r sin theta j cap and omega square. And we already know that r cos theta I cap plus r sin theta j cap equals to vector r. Therefore expression for acceleration in case of circular motion, vector A equals to minus r omega square, implies acceleration is directed toward the center of the circular motion, is directed toward the center. How did you find this video? I hope you now got the idea about how to find out expression for velocity and expression for acceleration by using vector differentiation. If you are satisfied with the video, then please like, share and write down the comments. The comments are very important for me. Meet you again with next topic. Till then, wish you good luck. All the best.